Then I'm saying, hi, Sanjeev. I'm very happy to have you here. And I would like to give you the opportunity to introduce yourself, and then we will dive right into it.
Sure. Thanks so much, Ilya, for having me here in the podcast.
What I always like to do is going way, way, way back in time and ask, so how is your journey and how did you start? What was your upbringing and your education? These are the things I'm very interested in because you can see patterns, but sometimes you see something very unique. And yeah, this is what I'm interested about.
Sure, sure. So I did my bachelor's in electrical engineering from IIT Roorkee. That's Indian Institute of Technology, Roorkee. From 2007 to 2012. Before that, like I mean, just like anyone in India, like I did my schooling, prepare for the JEE examination, which is required to actually get into IT. So I got admitted there. I opted for electrical engineering. Along the way, I got interested during fourth semester of my undergrad. I got interested into AI and machine learning, more specifically towards autonomous driving. I saw some of the videos by Team MIT for the DARPA Urban and Grand Challenges, DARPA Urban Challenge, and then DARPA Urban Grand Challenges, various videos by the various teams that fascinated me towards the area of autonomous driving. So at that point in time, it was January of 2009, when I had just entered fourth semester of my undergrad. I decided that solving the problem of autonomous driving in the most complex, adversarial, and stochastic or chaotic environment scenarios, you can say, for autonomous vehicles, is my lifelong objective. And since then, I sort of started building my mathematical background while being an undergrad. So I self-taught myself various areas of theoretical computer science and applied mathematics. So by degree, after undergrad, I was an electrical engineer, but um, uh, basically I was a theoretical computer scientist and mathematician, you can say. And some of the areas that have become like very prominent nowadays, like the area of reinforcement learning. I also saw some of the videos, the inverted helicopter project by Professor Andrew Ng and Peter Beal at Stanford University, that actually got me really fascinated towards the area of reinforcement learning. So when I got interested into autonomous driving, I mean, through machine learning and reinforcement learning, also like decided like that motion plan decision making under uncertainty, which is like sort of algorithms that that sort of control the motion, the behavior of the vehicle on road. That became my primary research sort of objective. So from fourth semester to fifth semester, I built tremendous amount of mathematical background, self-taught myself, kind of courses, kind of books that typically are taught during MS degree or PhD at top universities in the world. So that was about my undergrad. I initiated several projects at that point in time
Hey,
that
wait, wait,
actually.
wait. I put the pause button here, and I really actually would like to rewind some things because I think some topics are very interesting for me. First, I would even like to go back further. Is there any, like the foundation? Sometimes I have guests that have a very, let's say, straightforward CV with engineering parents or uncles or neighbors or whatsoever. So that is very common among a common pattern among deep tech founders. Is that something that was
uh,
with you?
that is not the case with me. My father retired as a forest officer, and my mother happens to be housewife. So it's just like during my school days, like I just interested into doing something related to robotics. But I mean, the kind of robotics that you imagine during the school days is like very different compared to the kind of robotics that you get introduced to when you're in college. So most of the foundation, like I always knew I had to do something in technology, right? I don't know why. I mean, the moment you decide, to go the JEE route in India, I mean, you are going for engineering, right? And I have always been fascinated by technology. So before this foundation of autonomous driving, before this goal of autonomous driving even came to me, even before that, during my first and second and third semester undergrad, like I had like gone through like various areas, teaching myself like you can say assembly language programming for programming microprocessors, building robots for robotic competitions in colleges, and teaching myself the field of image processing, how computers can see through cameras. That all happened like before my fourth semester. So the interest was always there that I had to do something technology. But if you talk specifically about the like in context of a startup and context of autonomous driving, the foundation was laid primarily during my fourth semester of undergrad. I think I'm the only engineer in my family. So
Mm. Thanks for giving that insight. Yeah, I always like to find out what is the environment that someone that is becoming a founder. What is it? Is there some patterns? Is there some so? But you said there is some incentive, motivation out of interest that brought you to this path.
one thing is for sure, like, I mean, it's about my life as well. Like, until I'm alive, I want to solve problems that are considered the most complex of problems, uh, you know, in the era that we live in. Autonomous driving happens to be the most complex problem in the world at large.
Mm.
It's a cutting edge R&D problem. Unless you're doing foundation R&D, you cannot solve the problem of autonomous driving. If you look at the education, if my other sort of like deep again, like, I mean, again, like education, solve the problem of education is one of the most complex problems in India. I mean, because the quality of higher education is not that great as compared to what you see in the developed countries. So, the bachelor's programs are good, but the master's and the PhD programs are not that great as compared to, the developed counterparts, all over the world.
Mm. Interesting.
So if you can solve the problem, you can actually solve many of the social problems as well, which are relevant mostly to India. And when it comes to transferring, I mean, it's the most as scientific as it can get, and it's very complex. It's very interesting. If you solve it, I mean, it can be the technology, the solution can be used in various different areas as well. But yeah, I mean, that's it. I mean, the transferring like fascinating undergrad happens to be the most complex problem as well, even today. And everyone is investing into solving it. Very hard. Companies are shutting down like all over the world. Startups who had taken like regular approaches, they are not able to make it work. So that's another like pointer to the problem is like really, really, really complex. So I mean, yeah, I mean, we are solving that problem.
The other point that was interesting for me is you mentioned it a few times. You I think you said something like self-taught, and here I would like to better understand, is that something that was because of the lack of quality of that, or was that because of the curiosity and drive that you had? Because a lot of people that coming from school and having very good grades in school, or it doesn't matter what kind of grades actually, but when you enter university, you're finally hitting a wall where you understand, actually, I do need to understand how learning works, right? Because the amount and the complexity of topics that are being thrown at me, especially in STEM, the first few semesters are always like filters, right? So the hard stuff comes first, and here's where the foundation needs to be laid. And yeah, maybe you can elaborate on that.
So one thing's like in India, like when you give the JEE exam, right? I mean, you get a rank, all over the India, it's AIR, all India rank. So, based on the ranking that you get your, like at the point in time, there are only like 7 IITs, and my all India rank was 1403. So that's like around like, in, top 0.3%, something like that, at the point in time. But even then, like, I mean, you don't have much knowledge about, what stream you would want to go, further, to be able to, what kind of problems you'd be solving. I mean, that relation, uh, that foundation, like whatever you want to call it, like it's not built during the school days in India.
Mm.
It's just a norm over here. So when I got into electrical engineering, I mean, I realized pretty early that these are not the courses that I'm going to study for the 4 years. So I mean, if you have an interest, so the self-taught thing, number one, like I was least interested in my college courses, so I had to like give up my grades. I mean, so my grades are not that great. Um, Regarding like what I taught myself in the undergrad, see, I mean, you may call it stupidity, but I wanted to gather all the knowledge in the world to be able to solve the problem of autonomous driving while I was an undergrad. I mean, it's stupidity, ambition, I don't know what you want to call it, but I mean, that was the case. And that is the reason why I actually ventured into, so during my undergrad itself, I initiated two self-initiated projects. And one of those projects have actually led to the foundation of Swaayatt. It was based on like I asked like myself very simple question, like how do autonomous vehicles navigate in environments that they have not seen previously. So fast forward, 15 years down the line, you're seeing the advent of startups who are trying to solve the problem of autonomous driving without relying on high definition, high fidelity maps of the environment. So these are some of the very foundational questions that I asked myself, very early on. And the mathematical background that I built, the kind of background that I built was, I would say, like many of the books that I read myself, they're typically covered during a 2 semester period in a top graduate program if you're doing MS or PhD. So I taught a book like that myself in 2.5 months. So I did that like throughout 2009 and 2010. So that's how I built my knowledge base in machine learning, reinforcement learning, mathematical optimization, motion blind decision making understanding. By the time I finished undergrad, I think I'd gone through like more than like, I don't know, like 250 research papers or so. I initiated several research areas. They were published later on in international journals and conferences, and that's all I can say about the foundation. After my undergrad, I went to Israel. I was a research intern for a professor over there, where again I was developing motion planning and decision making algorithms. That allow autonomous vehicles and robots to move at very high speeds in threatened environment. This research got published in the topmost robotics journal as well, which is IGR, or International Journal of Robotics Research. So
Sorry,
as an
sorry, and where was that? So when you did your master's?
So I did my master's from 2012 to 2014. I was at University of Alberta for my master's. But before that, after finishing my bachelor's, I went to Israel. I was a research intern to a professor
How was that
over.
for you? Because it's the cultural background, the cultural differences is huge, right?
It never mattered to me. So like, I mean, my undergrad internship was in autonomous learning lab in the US at the University of Massachusetts Amherst. So I'd already been outside the country doing my undergrad. And I mean, if you're a researcher, with that kind of ambition, probably the first thing you'd like to do is like get yourself admitted to some graduate program. And that's what my goal was like. So in 2014, in fact, I got admitted to PhD at University of Massachusetts Amherst, computer science fall 2014 PhD program. But I gave up that, came back to India in 2014. It's not like to start Swaayatt Robots, but my mother's health was not good at that point in time. So I had to like come back to India. I took 1 year deferred my admission from 2014 to 2015. I had 1 year to do anything. And I had like tremendous knowledge background built up like all the way from 2009 to 2015. I had also initiated, research, projects that actually got converted into full-fledged research projects solving very complex problems in motion and decision making under uncertainty. So with all that knowledge, with all that research, I had 1 year to do anything. So I started Swaayatt Robots, as a project. Let's see what happens. So whatever I worked on, like that knowledge accumulated. I also like when uh, when I realized towards like March of 2015, I realized like that I think that I can go on and solve the problem of autonomous driving, relying only on cameras for perception for autonomous vehicles. That's when I actually gave up the PhD offer.
Hmm.
So in April of 2015, I declined the offer altogether and started working on Swaayatt Robots full time. And when I started working, we did not have like any seed capital, anything like that, and the challenge was,
So, sorry, it it wasn't just you, right? Or was it just you? So
was
maybe you
just
can. It was
it
just
was,
you. So
was just me at that point in time.
so tell me more about this. I'm interested. So coming up with the idea, okay, this is something I want to do, and I think I'm able to do it. I'm not going the path down of a PhD where I'm working on some projects, but for someone else, like or for the thesis. But becoming an entrepreneur is something totally different, especially if you're so deeply invested in academia. And um, did you have any role models or any specific? I'm very curious about this. Any role models at any point in time, something that really made the difference or made you giving up one thing and fully being invested in the other thing. So what what happened back then?
So so you can see like during my undergrad, I had like a YouTube channel for myself.
Hmm,
I used to give lectures in these areas that we are talking about, including in reinforcement learning.
interesting.
And in every video, I mean, those are like very stupid videos now. If they were recorded when I was an undergrad,
Are
and
they still there?
they are still there on my personal YouTube channel. And in at the beginning of every video, you can see the photo of one autonomous vehicle from either DARPA Urban Challenge or Grand Challenges. So I was so deeply invested into autonomous driving, right? So that was an inspiration itself. If you're asking like how did I get the courage to actually decline the PhD offer altogether, for which I had like worked like almost for a significant part of my life, during the undergrad and after undergrad, I really don't know. I mean, it's just like I decided that this has to be done. Maybe like I got into habit of meditation as well, so maybe that helped me, take this decision somehow. I don't know how, but
Hmm.
I took it and just like never looked back again. I did not have any seat capital at the point in time when I started Swaayatt. And the challenge was like, I mean, at that point in time, Google, Uber, and Lyft level 5 division, these are the only companies that you have might heard of, trying to solve the problem of autonomous driving. At that point in time, everyone was invested into, solving the problem of, perception. That is like the class of algorithms, that allow autonomous vehicles to preserve visual sensory data and, perceive its environment. So, for perception, LiDAR was, the default sensor. So the
Hmm.
challenge was like I did not have computer vision and deep learning background by that point in time when I started Swaz. So for 6 months, I taught myself computer vision and deep learning. And I had research, mathematical research background, so it was very easy for me to connect all of these different areas. Uh, you know, and by 2016, we became the startup that actually solved the problem of autonomous driving without any lidar. If you look at like some of the prominent areas nowadays, I mean, you might have heard embodied intelligence, one of the like hottest talked about topics at CS as well. Wave AI in the UK is doing embodied intelligence. OpenAI is doing embodied intelligence. A lot of agentic AI that hearing nowadays, it's an instance of embodied intelligence. So the kind of the depth in the research was um, um, so high that by November 15, 2017, we did our first multi-reinforcement learning agent-based autonomous train demo. The vehicle used only two cameras. The demo video is still on our website, and all the 88 demos that we have done in India, they're all on our website. So actually, we became one of the very rare startups to actually solve the problem of autonomous driving, using only the cameras, because we did not even have funds to actually buy the lidar. If you had to buy lidar at that point in time, it used to cost like $100,000, that Velodyne 64-channel lidar, whereas the entire fund that I had for for 5-6 years was like $60,000, something like that. So I mean, it's a huge mismatch. So
But
um,
this is now the we, right? So this is not anymore you. And
this was, yeah. So during like so um, as a core team member, like I was still alone, but every summer and winter, every summer and winter, there used to be interns. So a lot of interns have come over here. They have done some like great work until 2020. Um, it was still like I was single-handedly doing it with tremendous like number of like 50 interns had graduated during that period. Some of the interns actually came for very long-term internship, and they have become full-time team member startup now. So some of the people
mm.
had joined the journey as back as like 2018, right? Some from 2020, some from like after we got our first round of funding in 2021.
So how was it for you to raise some money then? Because you said that you were deeply invested in developing the technology, which was very edgy at that time, and you said money was hard to get. So you're trying to survive with the little things that you had, and then as things get forward, because this is very crucial. I'm talking to a lot of startup founders, and they have an MVP, and it kind of works, and they get in contact with investors, but sometimes it's very hard to really lift out, to really, how do you say this? To really get this off the ground, right? To really get some grant money. And so how was it for you? And how get you connected with this? Because sometimes it is if you're in academia, you're not necessarily in contact with people that have money, right? And that can give you some money. So how is that for you?
So from 2015 to 2021, it was self-funded, family and friends. One of my friends gave me one I don't know, like in terms of Indian rupees, it was like 10 lakhs, which is like 1 million Indian rupees, which is roughly around, I think, 12.5 thousand dollars, in today's term. So I got support from my friends and family like along the way, but in cumulatively, I think in 6 years, we spent around like $80,000, something like that. So that was all I had. Like everything was, I bet everything on solving it. It did not matter like what there was going to be, what there's going to be in the future. I mean, you have to solve the problem. You have to solve the problem, and
And
it's
would
not.
you and would you do sorry, and would you do it differently this today in today's time if you had the same knowledge back then? Would you really going through that time? Because 6 years
I,
is a long period of time and
if I had known that this is what the journey was going to be, probably I would have gone for a PhD after
mm,
spending 1 year in India, one and a
mm,
half year. I would have gone for PhD. But when you start working on something, by the end of 2018, we did not have any money. So I launched DeepIgan to actually save Swaayatt.
mm,
So we started working on the second startup to save, because you cannot give on the problem of autonomous driving. I mean, if something really means you, you just cannot give up on it.
mm,
So I did some second startup like DeepIgan. We deliver online courses. Over there, we ensure the quality is like top notch. I mean, the courses that we deliver, they only the top graduate programs can compete with them.
mm.
No, compete with them. So, and I ensure that that is the case to run every course. So we started that like to save Swaayatt. And some of my friends give me some loan money, 10, $20,000 to actually build a safety net, so that, uh, you have some resources with you. And yeah.
What I see and what I can feel at least, or what I think is very hard to do to realize. Not the actually. I mean, it's also hard to do it. It's always much hard to do it than to think about it. But having the right mindset and actually approaching it like this. When you're a technologist, when you're an engineer, right, you're focusing so much on the problem solving, which is the basic, right? Which is the very basic element of founding something. But the second most important thing is solving a problem. So, and solving a problem needs to be tied to solving the problem for someone. So, when I'm being asked in the conversation that I'm having with very young founders, still being in university or just leaving university or being a PhD student, is solving a paying customer's problem first, right? Or finding a paying customer first. And if you're here trying to find someone who's believing in or who's having that kind of problem, now you could argue there's no one out there who has the problem. I would like not to drive the car on my own. I would like to someone. This is very unique. I need to admit, and especially in deep tech, some of these problems are um, not being very visible, right? And you would like to push the technology further into something that has not been there yet. But nevertheless, finding someone who is believing in you and who is saying, okay, there's actually a problem that I would like to being solved, and here's the money, and we are going through this hard times together, right? I think it's a very legit way and a very valuable lesson that you don't need to be all the time because you were able to find friends and family believing in your idea and giving you the money so you can pursue your ideas and technology. But there will always be some outsiders, so to speak, right? Where if you have the skill of storytelling, if you have the energy and the will and the knowledge and expertise, you might be able to find some money outside, and that could accelerate some things, right? But there's no good and wrong here. It's just an idea for the listeners.
So a lot has changed in India, like since then. I mean, you can see investments in R&D as well. But at that point in time, like typically in the VC ecosystem in India, typically the investments don't happen in cutting edge R&D. And one of the goals, like I've already mentioned, like I had given the PhD, which was one of my lifelong objectives. In my undergrad, if you come to me like, what do you want to do in life? I'd say like, I want to solve the problem Thomas trying, but I also want to do a PhD.
Mm.
And I one of the top 10 PhD programs. But so when you're giving up something, you're giving up for a very deep reason, right? And the reason was to actually be at the forefront of all the research frontiers related to AI and autonomous driving. One of the things is like with problem like autonomous driving is like most of the problems if you're going to get in, if you're trying to find customers in India, because I'm in India right now, so anything we talk about has to involve that context as well, right? So if you go in and invest too much time to solving rudimentary problems, you may not be able to build the kind of system, or the kind of technology, or the kind of solution that you actually have in mind. So it's not like that we are just like solving the problem, the technology problem. It's just like, I mean, okay, fine. I mean, Jensen Huang, like just like in the CS mentioned that physically the robotic industry or the self-driving industry is going to be first $1 trillion industry. If you look at the foundation of Swaayatt, I mean, since we invested from day one into foundational R&D, you can see I think we are the only exceptional startup, in terms of all the startups that are working in, we are the only exception who is doing both on and off-road autonomous driving at the same time. I mean, the only other example you can find is Kodiak Robotics in the US. But if you can look at the tech, look at the funding, the amount of resources and the amount of support, the infrastructure support that they have, and look at the kind of work that we have done both on and off road. If you look at like some of the startups like Overland AI in the US, who actually a team formed out of the DARPA RACER program, they are doing only and only off-road autonomous driving. If you look at it like Tesla, Waymo, Uber at that point in time, or any other transportation company, technology company, they were solving if you look at Deep Map, companies like Deep Map, they solve only and only the mapping problem. So the companies solve only the sensor problem. We did not, that was decided from day one. We are not going to be XYZ solutions company. We are not going to be going to be a company who's focusing on one single Gotham developing certain ADAS solution for certain ADAS solution. It has to be the entire autonomous driving, and it has to be without the LiDARs, because initially we did not have, maybe if we had funding, we would have started working with LiDARs, but since we did not have funding, this became the necessity. I mean, if you want to do a startup, you have to solve the problem, but look at the benefit out of it, we have in total, we have raised $7 million. $3 million was raised in 2021. Another $4 million was raised in last year, June. And all of this funding has come from the United States, actually. So an angel investor in the US has invested into us, right? So now, if you look at the, if you look at the kind of technology that we develop, if you look at the off-road autonomy program, our technology is at addressing, the problems that are being laid out by the DARPA and the US DoD, and some of these startups who are completely vested into solving those problems, they're not, for example, I mean, let's talk about bi-directional negotiation, where autonomous vehicle, so many of these companies are trying to, go for corner cases. If you take the Indian context, which is the most complex of the traffic dynamics imaginable autonomous vehicles, every case is a corner case for the companies in the West. So let me take an example of bi-directional negotiation. What this thing is. So assume you have a single lane road and bi-directional traffic active, which is very common in India, right? Whether autonomous vehicle should be allowed to do it or not, that's a very different question altogether. But let's focus on technology part, right? So if you have an autonomous vehicle that can negotiate this road with bi-directional traffic, just like human drivers do, you're never going to be worried about corner case. So I became the first company in the world to be able to solve the problem of bi-directional negotiation on single lane roads. The second company, I mean, which is a company that has raised $1.05 billion in the UK, like Wavy, they solved it like 1 year after us, doing only one single 10 demo. If you look at off-road autonomous driving, none of the companies, be it, even if you look at the defense contractors like Oshkosh Defense, or so the major defense contractor, or any other startups like Overland AI, Kodiak Robotics, or take any startup for that matter, no one can show bi-directional negotiation off-road. So the technology is heavily dependent on the availability of maps. Since we kill that, we have the kind of like the foundational research that we have done is specifically in decision making under uncertainty. That is allowing us now to have this solution that is addressing the problems of the world at large that they're facing in autonomous driving.
But pointing out these uniqueness and the, as you said, on the forefront on all of these companies, right? And the limited resources that you are having, plus the the complexity that is not comparable with any other cities in the West, right? Um, as an outsider, I would ask myself, so how is it that the money that you're raising is so far away from the money that these companies been raising? And additional to that, a lot of the companies took out or ended those kind of research projects, right? I mean, very famously, there is Apple that is not developing an autonomous car anymore. And I mean, who has more money and more resources and network, right? And knowledge and expertise. So my question here is, wouldn't it be, because I think it's actually a very obvious question. So if you are so developed and so forefront, right, when it comes to the technology, why, and the money comes from the US, why not going to the US, establishing a second company or leg? And is that something that you have in mind? Because it seems like the
We are
opportunities
going to
over
do
there
this.
would be, please.
We are going to do that this year.
Mm,
We have an objective to have this company registered in the US. It has been there like since we raised our first round funding, but we waited for the second round. Currently, we are sort of in talks for raising a major round. With that, we'll have a second office in the United States. That is one of the primary objectives for this year. You asked about the knowledge and the solution and the problem being very hard, and many of the startups, if you look at like entire autonomous industry, everyone just copied Google back in time. Now
mm,
it is Waymo. Everyone copied the model of Google's autonomous driving, you know, which was developed primarily for enabling mobile robots, navigating in not so chaotic environments. They have taken this model that the autonomous vehicles need to have perfect map of the environment, and you solve each of the problem, independently, and have a cluster of algorithms, working in autonomous vehicle, and building the representation about the environment for you, then fetching some information from the maps, and then the rudimentary planning algorithms, right? This is the first thing that we killed at Swaayatt. The field of embodied. If you look at the approaches taken by the companies now, they're trying to solve the problem end to end. This, which is not like behavior cloning or end to end reinforcement I'm talking about, but in a manner that rather than having a bunch of algorithms, you have sort of an end to end learning system that builds certain representation of the environment where these agents can act without requiring holistic representation of these bunch of other algorithms. This is a kind of problem, and this is a kind of the kind of frameworks which I was working at that point in time, where it's specifically addressing these problems. And since we had worked on these class of problems, and the kind of approach that we took, in 2016 and 17, we are talking about. Currently, I mean, these approaches are becoming more and more prominent with the success of recent startups like the OpenAI and DeepMind, and in terms of downswing, you have like Wave, you have like Helma in the US, and a lot of other these startups like have very recently started focusing in these kind of solutions. So it's a very approach that we have taken that differentiated us from the startups that are trying to solve the problem at large in the West. And most of the companies that you see that were shut down, the kind of approach that Google took at that point in time when they had their self-driving program, only very deep-pocketed companies can sustain that kind of program, right? And if you're just copying their model of autonomous driving, trying to build use case, you cannot have a robust business model unless you address the very fundamental problems relevant to the industry at large, which is safety, number one. And the second is like cost effectiveness, right? Unless you address these problems, you're not going to have a viable business plan. Google can sustain, their robotaxi program because they're very, very, very deep pocketed, right? But it's just taking that approach without innovating in terms of the kind of, the technology frontiers that you're working in, and try to scale those algorithms in a blind fashion, hoping that you may be able to make it work for some business. It's not going to work because the planning, if you look at the motion decision making underruns, right, the entire field of motion planning, they cannot take the probabilistic representation of the environment into account. If you take the probabilistic representation of the environment into account and sort of try to like fuse up motion planning algorithms, your problem will get converted into chance constraint formulation, which is the NP harm, right? So you have to address this fundamental problem. So the approach that we took from day one was innovating the motion planning and decision making, and giving up on these algorithms that had to be mastered to actually build the perception and the sort of to build the representation environment through like various perception or the mapping algorithms. We instead had like in terms of this is what embodied intelligence is like. Can you build a holistic end-to-end representation where these agents can act? Right. So these kind of innovative approaches that we took very early on that actually differentiated, and in terms of like the the money and the cost. See, I was working for myself, and all that mattered to me was solve the problem. And I'm being a researcher, built up the mathematical background through since undergrad. Like I was working for myself, so I could keep the cost low. It's not that we solved every single problem along the way. No, I mean, but the problems that we solved, we ensured that we are like much years ahead of the industry at large. Right? If you look at like by 2018, we have 35 demos on our website before even we got funded. The first funding came in like 2021, and some of these demos were like totally like using only the cameras without any lidar or radar on the vehicle.
Is that something that you would say that the environment forced you guys somehow, and the way that you were approaching this from a very how do you say this?
Very good question.
Knowledge-wise, deeply intact, invested. Do you think that the environment was one of the key differentiator that you took different approaches than the West? Because you cannot start from a very simple place and then gradually coming to the more complexes, but because you said this early on, there is no very simple traffic out there in India. We need to start with the most complex things first, because otherwise there is no point in going out there. Is that where you think this is the big difference?
I think it's a very good question. I think it is both. And also this third factor that we did not have a lot of funds. So whatever you do had to be, whatever you're doing at the point in time has to be cutting edge. And you have to ensure that it really solves a problem in very limited budget without relying too much on the exorbitant amount of data. So I can give one very simple algorithmic example, right? I mean, one of the very simplest problem for ADAS is like, the vehicle should be able to keep its lane, right? And produce lane departure warning. What would you do if you don't even have lane markers on the road? That would be a huge problem, right? But that's a regular occurrence, in India. I mean, roads are not well paved. So we initiated a research frontier. We called it before. This is before the advent of generative AI. This is before even the advent of generative adversarial networks. That became very prominent. In 2017, 18, and onward. In 2016, we initiated a research frontier known as delimiter generation, meaning us developing class of algorithms, deep neural networks that could not only sort of discriminate the information that is present in the visual sensory data, but can they also have this ability to predict or better generate such information points, delimiters to be specific, so that in case there are faded wraps on the road, the autonomous vehicle, if their automobile generated with that it should have been, the autonomous vehicle could perceive its environment as being structured. And if you can look into, like, you can go to a website and see lane detection and generation. There are like 10 demos just for this one single algorithm. And we ensured that this worked both during the day and at night.
This is
And
crazy. But
so first you have to identify the problem, because the environment is like very different, right? Then you cannot rely on regular approaches taken by the world at large to solve discriminative problems. You have to mathematically innovate, significantly, So if you combine the two, and then you also have to ensure, see, you cannot have exorbitant amount of, fused data from lidars, you cannot have mass where you can get artificial, generated data from. You have to ensure that everything is like, done in minimal amount of data. So you have to mathematically innovate even further to ensure that, let's say if you're doing deep neural networks, then the loss function, the constraint mechanism that you have, any mathematical constraint or any loss that you have, it supports, it facilitates the kind of learning that you want out of that machine or out of that AI system. All of these three combined actually led to, I think, some of these very innovative projects over here at Swaayatt. And these, like, 5 to 6 projects laid on the foundation of entire autonomous driving, over here. If you look at our recent demos from early 2024, they were done in kind of chaotic traffic dams that is unseen before for autonomous vehicles at large. You can see some of our demos from January, February, and March of 2024.
I
And
think
see
this was the time, sorry to interrupt you. I think this was the time where I first got in contact with the guys because I think I saw some videos on social media and then said, this is totally different from the very normal daily traffic that you see in the West. But here my question is, it seems like again, due to the environment and the lack of resources, you guys were because I was talking with a friend of mine about this. Tesla was one of the few that was really not going down the road with LiDAR, right? And it seems like because this is expensive, you guys didn't go down this road either, and everyone else was laughing about this and at Elon Musk and Tesla, right? Everyone is doing it. Why are these guys having a different approach? And you say we're having a different approach because this was something that we need to deal with back then because there was no availability of this technology for us. Is that true?
Sure. I mean, you wouldn't have a startup if you needed like $100,000 for a sensor, I
Yeah.
mean, we bought a second-hand vehicle that cost around like 400,000 Indian rupees, which is like, I mean, at that point in time, would have been like 20,000, 15,000 like dollars in the US. So, I mean, that's the kind of vehicle. We bought regular cameras, whatever the quality of the cameras was. We ensured that the models were like very, very robust and they work both during day and at night. We use like regular NIR cameras to ensure that we solve this perception problem during the nighttime. And we took like when we developed these algorithms, we took two simultaneous approaches. One was embodied intelligence approach, and one was like regular approach, but innovating significantly in the algorithmic capabilities to actually solve a certain class of problems. And one of the areas that I specialize in like is motion planning and decision making under uncertainty, which is like the motion planning algorithms control the motion, the behavior of the vehicle on road. And the approach was also very different. See, typically, if you look at the background of people who do motion planning, this is they do only motion planning and they have like control theoretic background. And people who are from computer science background, they only do sampling based kind of motion or path planning. Mostly they do sampling motion, sampling or something was like rapidly expanded random trees RRT or procedure. I came from background where I took very different approach, solving the problem of motion planning through reinforcement learning, right? Which no one was like, if you had asked anyone, the problem of, is motion planning, a challenging problem to Thomas, because they would have said, if you ask people in computer science, that motion planning is usually solved problem, Whereas if you look at, in 2005, that is the hottest area of research right now in autonomous vehicles, industry, right?
I need to. Sorry, I need to leave that part of technology because this is way over my expertise here. So I don't want to because it seems like today is a very technical episode, which I always like. But the idea behind the podcast is more let's step one step away from the technology part, and let's maybe trying to focus again on you being here because I see that you're an engineer by heart and that you're really focusing and have the energy and the dynamics of being fully invested in the technology. What I'm interested is always the part where you need to leave that, right? Because this is this is the foundation and base. You cannot neglect it, right? But a lot of tech startup founders, and this is what the podcast is all about. I will have a change of name in the next few episodes when I finish the 50th episode, because at the moment the name is Kinematic Conversations, right? But I would like to give an idea what the podcast is all about, and this is like building deep tech, right? So you are an engineer by heart and you know how to be an engineer and to do engineer works, right? But if you would like to make this reality and if you would like to bring this to life and bring this to the customer, then you actually need to become an entrepreneur. And here the problem is that you spend so much time in your education in being an engineer that you lack some sort of experience and skill when it comes to become an entrepreneur. Micropsy Industries and company that I was working for a few years ago, for a few years, is do AI vision for robots, right? And here there are deep tech founders as well. And I remember that I was talking to the head of or the VP of sales that they were begging for 2 years for the sales guys to get a robot so that they can take the robot to the customers. So to show what the robot and what the software, because it's a software company, what the software is really able to do. And it was totally unnecessary for the founders. I mean, that's at least what I heard, that it's totally unnecessary and the money needs to be spent into research and to develop the software. But the sales guy says, look, I mean, you guys think that we can sell this software, this product over some video calls, right? Because this was back in during COVID. But people are hands-on. And if you would like to having your product deployed into a factory, then you need to talk to operators, shop floor managers, line managers, plant factory managers. These are the people that you're talking to, and engineers on site, right? And they would like to touch. They would like to see how robust is the robot. And I'm going down this path because I would like to better understand. And you said you were funded because maybe the situation here is a bit different because you were funded by friends and family who are not necessarily the user or the ones who will buy. I mean, maybe in the future they will also enjoying the fruits of your work. But normally speaking, you are talking to a future customer because he will the one paying the product, right? He will be the one using the product. So it's not so much about the technology. It's much more about the adoption. It's much more about the interface he's facing it, right? The way he programs a robot, he's using a robot, or maybe the shop floor person, the operator, who doesn't understand even the technology, but he's the one who's using technology on a daily basis. So here you need to understand how to sell a product. You do need to understand how to market a product. And maybe we can spend a few minutes on this part. How was that for you? And how did you learn this? And did you have people in your life telling you about this? Maybe you can go down this road.
So I can begin with answering the first question, when the customer, and understand the market, and taking the business approach as well. So I mean, since before funding in 2021, like solve R&D, because um, that was, you had to solve the problem to ensure that you have safety, and and the parameters that you really care about, those parameters are there. Once you have that, if you look at our journey after 2021, we have expanded to all frontiers of autonomous driving. And over the past like 2 years, this is all because of very deep R&D that we have been doing. If we had not done that, we wouldn't have had this kind of capability to actually provide a solution, to OEMs at large. So the past 2 years, we have spoken to almost every single OEM in the country. And what we realize is like the requirements are like very rudimentary in nature. And we realize, okay, fine, that the solution that we're going to develop this year, because we have $7 million in funding, it would address the ADAS requirement, for most of the OEMs in the country at large. All that matters, like now fusing the software that we're developing with with the compute hardware, and we are looking for for hardware partners to actually build the SoC, or to deploy our software, right? So like for example, like Indian ADAS market is like, I would say, like autonomous driving in particular, but again, like as I said, like autonomous driving, like what we are solving is not just limited to India. What we are developing something that works even in India, right? And there's a huge difference, in that. But you look at the ADAS market over here, that's humongous. By 2028, it is projected to be around like 30-40 billion dollars, of market. And I don't think like any player in the country has a capability to actually provide the kind of solutions that these OEMs are looking for. And we are talking about both the Indian as well as the foreign OEMs who have a division over here in India. We are talking about like top European, top US OEMs as well. And since we have spoken to them, like we have learned like all the problems that they want to solve, we are solving those problems by default. We last year, like I cannot go into the details. We are at very advanced level of talks, and raising a commercial POC with one of the major OEMs in India, related to campus autonomous driving. There are certain other OEMs as well. I mean, that we're talking to, for various either standalone features of ADAS or for complete ADAS solution. So you would see like the solutions, the technology that we have been developing over the years coming out in the market, hopefully this year. by the end of this year or early next year. If you talk about like off-road autonomy, you mean like why are we doing it? Number, we already discussed the US endeavor, right? I mean, definitely like once you raise this major round, we will have an office in the US. If you look at our off-road autonomy, it is not just about R&D. It's about like, I mean, if you want to see by 2030, I don't think like more than like 4 or 5 startups would be there trying to solve the problem of autonomous driving. You have to ensure that you are one of those 4 or 5 companies globally that are providing solutions for autonomous driving. And to be that, like, you really have to if you don't address, see, many the approaches taken by many of the companies in the West is like, fine, let's roll a small solution, let's scale it up. At scale, we'll figure out problems and we'll try to address them. There's a human amount of resources and funding, and the team, which is okay. I mean, I don't deny that, right? Because I'm also doing an education startup at the same time. So I know that the customer really matters over there. But if you look at like at Swaayatt, see, you cannot pitch quantum computing if you don't have the technology to actually solve the problem of quantum computing. In terms of autonomous, it just became so easy because these deep learning models that you have, they actually uh, make any sort of appear that they really have. But unless you address the problem of like real-time compute efficiency and the safety, you really don't have any business plan. So if you want to be one of those 4 or 5 companies all over the world, you have to really address the pain points, like what are the reasons like why your entire business would fail. If you, because identify those factors, you have to address, and the R&D is all about addressing those parameters. Now coming back to off-road R&D, if you look at like Indian like military complex is a humongous market, and the kind of solutions that we have developed, I mean, if you look at the requirements from the armed forces, I mean, they are not that R&D oriented, and we are I think I cannot reveal too much over here. But yes, I think the technology we have developed would be in the market, either in collaboration with a major OEM or standalone, a solution developed by Swaayatt. And if you look at like, the kind of, very recent demo that we did was, vehicle was navigating near drift speed while doing obstacle avoidance. You can look at DARPA RACER program. The goal of that program is to drive vehicles at near human-driven speeds off roads. That's very agile kind of, autonomous driving. Now, even you look at the startups who are trying to solve the problems, over there. I mean, they can do high-speed navigation, but they cannot do obstacle avoidance at the same time with high-speed navigation. So the problems that we know that the world is going to face so and so problems. If you talk military application, so and so problems. If you talk ADAS, so and so problems. If you talk campus or the regular on-road concept, we're actually addressing those problems with our deep R&D and our technology. It just appears like that we are only focused on R&D, but it's not the case. We are doing this off-road R&D too, because off-road autonomous driving, specifically for military application, is a humongous market. And as I mentioned, like I cannot reveal much, but we are in talks with various stakeholders for the deployment of the technology and commercial capability.
I mean, deployment is one of the key points, right? That that a startup very often has no experience about, right? I mean, I don't have too much experience in bringing cars on the street, but bringing the technology into manufacturing, into the factory.
I lost your voice.
Oh, yeah.
It's back.
Yeah, no, you're back. I said that my experience is not so much bringing a car on the street, right, and all the problems that you need to face over there, but more how to develop a car, or like in manufacturing, right? And here, so the environment might be a little bit different, but the deployment part is always hard. Coming towards the end of the podcast, you said already that one of the major plans for you guys is entering the US market. Also being in talks with a lot of OEMs. You also mentioned very briefly that you're in talks with automotive in Europe, because they are desperately looking for some solutions to save their asses. Speaking very brutal here, but how many people are you in the company now at the moment?
Currently, we have a team of 20 engineers as of now.
So This is an interesting point too. So the majority of company is made out of engineers, no project manager, no.
So
Uh,
in that sense, like we have a team of 30, but the
uh,
core engineering team consists of like 20 engineers.
Nice. Because it's always advisable, especially if you need to work with limited resources, to not blow up your team with some project managers and then in some unnecessary roles. But like I said before, um, the commercial side is the commercial part is definitely something that not needs to be under or neglected. But it seems like you're closing that bridge with everything else only starts to matter if I'm able to solve the technology problems first. And I think this is very true. And maybe because the pull is so big in the market, like everyone would like to have a fully working, because I mean, Tesla is promising this since 2017, I think, a level 5. It's still not there. And so maybe here we really have the exception that everything else is only possible if the technology is working safely because you're driving among humans. But my last question would be the the safety part aside and the technology part aside, is that something that is there something that you would like to give yourself as in being now an entrepreneur and being an engineer for the majority of your life now? Is there something that you would like to tell yourself? Like if you could go back in time 4 years, 5, 10 years, is there something that you would like to teach yourself, a younger version of you? Not being an engineer here, but being an entrepreneur here.
So I wouldn't have changed the approach that we have taken at Swaayatt, but yes, there are things we could have done differently in terms of business to maybe get funded early on. For example, like there are already like couple of, as you mentioned, like there were a couple of software, that you developed along the way that could have addressed the ADAS problem back in time. We are this to 2016, 2017, we are talking about. But yes, due to lack of resources, and with the resource, I mean that both the human as well as the capital as well, the lack of resources, we couldn't take the solutions to market. You know, so maybe there are some things from business standpoint I would have done differently. If you're talking very at a very personal level, then I got into meditation in 2013. Probably I would have started that early on in life.
Mm,
Uh, because the journey was like very, very hard, and there were like lots and lots of moments of giving up because you do not have any funds. I mean, you still want trying to solve the most capital intensive problem, one of the most capital intensive problems in the world. You know, so I think that kept me going. You know, I'd also had like one more point since we're talking about the markets and the industry and the other players, the large teams. Along the way, I've spoken to many of the companies that have gone bankrupt, in
mm,
last time, right? I don't know whether this should be confidential, if we can speak about it in a podcast. I'll just share the information for your reference. I mean, take an example, Navia in France. It was like I found the company to be a bit naive and a bit arrogant as well. I mean, whoever spoke to it back in time, their shuttle used to cost like at $220,000. This was version one. The next version was around 400, half a million or something, or $300,000 something. 300 from pounds, I guess. And I approached. So you mentioned like collaboration and all of these, business of. So with the technology that we have been developing, since we did not have funds, in that capacity, I mean, so all we could do was talk to these companies, talk to the executive team or the like, key stakeholders, over there, and everyone represented, see, we can reduce the operations cost for you because we already have a technology that can reduce the number of sensors and the number of radars in the vehicle. But I think everyone, like including like companies like Fisker, who had an ambition to actually do both EV and autonomous. I reached out to Hendrik Fisker. Maybe we shouldn't incorporate this in the podcast, but yeah, I mean, just letting you know. So I approached him over LinkedIn. I said, like, we can see solve it. He said, like, we have a team of 40 engineers of our own. Why do you think we would need an outside? So many times I felt that the industry was naive at large, and
mm,
the naivety also came arrogance because like
mm,
the problem is like really real. This is again I said like you cannot sell nuclear fusion without having proper technology for
mm.
fusion,
I
right?
mean, in the VC game, you can, right? And this is some part of the VC game that you're selling a dream first and
But
that you're building
they,
the technology up.
there
behind?
should be a way forward. There should be a backing to it. Like the approach that I had taken, at least I can speak for myself. Like the approach that I had taken in life was like really solve the problem first and like ask for everything later. But I mean, as I said, like there are some things we could have done differently in terms of business. So maybe we could have funded like a lot early on. So there's a lot of learning that has also happened along the way. I wouldn't deny it. And with all of that learning, we are still learning today as well. I mean, last year we like came very close to raising a commercial POC with one of the OEMs. It did not work out, because we are in the business of not sharing the IP.
Mm.
This OEM required, like, joint ownership with IP.
Mm.
I said we don't do that. So we learned, okay, fine, like we have to, mature in terms of like the both the hardware and the software part as well. And so find a partner. So it's not like we suddenly decide, okay, that we go into hardware. So no, just find a partner for developing the SoC or the hardware and deploy the solution and take the solution to the market. You don't have to like do the homologation everything on your own. I mean, you can have these larger ones who can in collaboration you can do this. So there's a lot of learning along the way. We are still learning, and I think like as we grow, both in terms of team and in terms of maturity as well, like I think and past experience and the hardcore R&D, everything taken into account, I think we do a lot better this year and the coming year.
I'm very excited for you guys. I'm very curious to see what you guys will be able to pull off, especially entering the West. And it's so funny that you're like starting with the most complex part first, right? Everyone else is driving in very safe environments and now entering the streets, and now you're driving around in San Francisco and other cities in the US. But nothing is compared to places like India or Asia, Southeast Asia. These are very chaotic places and very challenging environments. I'm very curious to see how you guys will continue your work, because you have been in the business for quite a while now. And as you said, a lot of big players already tried the game and they pulled out. So I'm very happy for you guys that you made it until this point. And I'm very curious to see where things will go into the new year. I would like to say that whenever you, because I saw the videos, right? And I'm keen to see this working in reality and being part of this, because in San Francisco it's very easy actually now today to just order one of those cabs and just driving around. But it would be interesting to see how you guys will perform. Will you be in the West, or in Europe in the near future?
Let's see. I mean, if things go well, I
Okay,
might, um, you know,
let's
otherwise
see.
let's see when it happens.
Hmm. I would like to say thank you very much for taking the time and for going so deep into your company and sharing the journey. I think this will be very exciting for people who are interested in cars and autonomous driving. I have a few friends in that area, so I'm happy to say I'm very happy to have you as a guest and share this episode in the future.
Thanks so much for having me in your podcast.
Um, let's say I would like to come back to you at the end of the year, see what's happening, because I'm continuing this podcast anyway. So let's see. And I'm saying this to a lot of my podcast guests, but here I really see that there's some excitement, especially as I'm in Germany. I'm near Stuttgart, so Germany still is some sort of a automotive um, country, right? And we are still the only company in all of Europe that doesn't have a speed limit. So I think they're very proud of that. But looking at the numbers, how much they sell, I think there will be some very hard times coming towards the German car industry. And I don't know, maybe there are some talks that you're having with German automotive, and let's see what's come out of that.
Sure, for sure.
Then take care and enjoy your day.
Thanks so much, Ilya, for having me on your podcast. You too as well. Have a nice day.
Bye bye.